Hi everybody, this is a video for Math 180 and I'm going to be talking about section 13.5, 13.5, the section on volume. And what I want to do is think about some of the formulas for volume of some of the different objects. And I want to, as much as possible, make it so that we're learning them not just as rote procedures without connections. We want to have those procedures connected to some understanding. So the goal is procedures with understanding or connections. So understanding. Okay, and let's start with like the most basic one that we all know pretty well, a box. So we know, most of us remember pretty easily and learn pretty well that if you have a box, which is a right rectangular prism, okay, that you need to know the three dimensions. You need to know the length, the width, and you need to know the height. And if you know those three dimensions, you just multiply them together to get the volume. Length times width times height. Right? So that's kind of the formula we often learn. And we learn it without any understanding. We just learn it. It's pretty easy to learn. You practice it and then you use it. But let's try to make sense of it and then see how it would help us make sense of other things. Okay, so let's say this was a box and we were filling it up with cubes. Actually, let's do it. Let's say we had a box that was 3 high, 1, 2, 3, 4 long, and 2 deep. Okay, so I'm just trying to draw it as best as I can. Okay, so let's kind of think about, what if I were going to try to fill this box up with 1 by 1 cubes? Well, you do sort of one layer, right? If I did one layer, then it would be 3 by 4 individual cubes, right? It would be 12 individual cubes. So it kind of makes sense. So one layer is 4. Wait, I lost it. This was supposed to be 2. Sorry. One layer. It's a little bit awkward now. It's 3 high, not 2. Let me try this again. See, it shows you everyone makes mistakes. Okay, let's say it was 3 high, 4, 1, 2, 3, 4, and 2 deep. Okay, 3, 4, 2. One layer would be 4 by 2. That would be 8 cubes. So you'd say each layer, a layer is 4 by 2. And then the 3 tells you how many layers, right? 3 layers. So the idea is you do this once, 8 cubes. Second time would be another 8 cubes, and then you'd fill up the top layer, and it'd be 8 plus 8 plus 8, 4 cubes, 3 layers. So if we think about this formula, what we're doing is we're saying it's 4 by 2, that's each layer, and then you multiply that by how many layers. So each layer, and this is sort of the number of layers. Or another way to think about it, a little bit more abstract than this, is you've got that 4 by 2 rectangle on the bottom. Okay, and it's getting pushed 3 high. So you can think of volume as an area that's getting pushed through a distance. So you start out with an area and you push it through a distance. So you can think of it, the volume is the area times the height. And the way to think about this maybe is, instead of layering, you think of it like a syringe, or like one of those things that you use, like the kids use to push Play-Doh through, right? If you have a rectangular hole and you push the Play-Doh through, it makes a box-like shape, right? So area times height gives you the volume. Area times height gives you the volume of the box. So this formula up here, the way to think about it is with parentheses. Think of it as area times height. So the volume of the box is the area of the base times the height. And you can think of that in terms of layering 1 by 1, or you can think of that in terms of sort of pushing an area through a distance. Okay, why make such a big deal about this? Well, if you think about it this way, then you can generalize from a box to any prism. Well, any right prism. So, a right prism. What is a right prism? A right prism is some base that there's 2 copies of it and they're directly over each other in space, so that all of these lateral sides are rectangles. Right, so all of these sides are rectangles. So you've got 2 bases and they're spanned by rectangles. And here's the idea for volume is, think about this area here, the area of the polygon that's the base, and the height. So the volume, just like a box, the volume is going to be area of the base times the height, right? If you had layers, you could stack them up 1 by 1. If you didn't want to think about it as layers, you could just think about it as pushing it. So the volume is the area of the base times the height. Now, with a box, we knew the area of the base. It was just length times width. But in general, you may or may not know the area of the base. That might be something you have to figure out. But if you figure out, or they give you the area of the base, and you know the height, you can find the volume. And it's kind of the same thing like that, pushing the Play-Doh. If I had a hole that was a pentagon, and you do the little Play-Doh machine and push the Play-Doh through the hole, you'll get this bright pentagonal prism. Okay. And now let's think about cylinder. Well, think of like a tube of toothpaste, right? You've got a circular hole and you push the toothpaste through and you get a little cylinder of toothpaste. So the same thing, you need to know the area and the height. The volume of a cylinder is the area of the circle. That's the base times the height. But aha, if we know the radius or can figure out the radius, we can make this pi r squared h. So this is a formula you often learn, pi r squared h for cylinder. And I say it helps to think about it this way. Pi r squared times h, the area of the circle, that's the area of the base, times the height. Okay, so this is a really kind of useful idea. If I have an area pushed through a distance, that gives me a volume. And to find the volume, it's just the area times the distance. You know, I like to think of like if you stack quarters, right? You can find the volume gets longer as the height increases. Okay, so that's something that's kind of cool. If you want to do prisms, right prisms, or cylinders, you've got this really nice formula, the area base times the height. Now, what happens with like a pyramid? So what if I have a pyramid, say its base is a square, right? And say, like this, say its base is a square and its height, let's say its height is whatever this is. Well, and so the height would, I mean, like if you dropped straight down from the apex, it's that distance, that's the height. So not the length of the side here, but the height straight down. Well, the area times the height, that gives you a prism. And we've got a pyramid. But here's the relationship. The volume is the area of the base times the height. That's the area of the prism, and it's 1/3 of that. So volume of a pyramid is 1/3 of a prism with the same base and the same height. Kind of cool. So if you know whatever your base is, whatever your height is, think of it as not a pyramid, but as a prism. Let me draw it here. I think you had a prism. Right, that had the same, this is not drawn well, but that has the same height and the same base as this pyramid. This has 1/3 of the volume. Now, why 1/3? At this point, it's sort of a mystery. You can make a demo of it. If you're working with kids, if you had like a prism that was like a box and you had a cone that was like the pyramid with the same height, you could fill this up with rice and like use it as a scoop, and it works. If you did 3 scoops, it would work. So the volume of this pyramid really is 1/3 the volume of the prism. And you can demonstrate it, but that doesn't really derive it. So at this point, this isn't a formula that we fully derived. It's just one that has some connections. I'm telling you, it's connected to the area of a pyramid is connected to the area of a prism. Kind of cool. And similarly, the area of a cone is 1/3 the area of the cylinder with the same base and height. So if we've got the height and you've got the same radius, then the volume of the cone equals 1/3 pi r squared h. So pyramids are 1/3 of the corresponding prism. Cones are 1/3 of the corresponding cylinder. Okay, one last thing. Unfortunately, spheres, the volume for a sphere, all you need to know is the radius. But this formula kind of comes out of nowhere. 4/3 pi r cubed. I do want one connection we can make is the fact that it's r cubed. And that makes sense because of volume, right? If, say, r was in inches, it'd be inches, inches, inches. It would be cubic inches. So at least the exponent makes sense. Why is it 4/3 pi times r cubed? This is not a formula that I can kind of readily establish for our class. So this is kind of an example of a formula that there's not a lot of connection to. At this point, it's just kind of a formula I'm giving you and saying this is the right formula. You know, memorize it, use it, that kind of thing. So that's one nice thing to think of is how, you know, this formula we can totally make sense of. And then that generalizes to these ones. So we can make pretty good sense of these. And these are connected to these two. So we have some connection here. And then here's one, a sphere that I've offered you no connection. You can derive this and make sense of it with calculus. It's pretty difficult to do without calculus. One thing I can do, and the last thing I want to try to do on this video, see if I can get a thing here, is there's a really cool little thing, is let's say I have a cone, a sphere, and a cylinder that are kind of similar. So let's say I have a cylinder like this, and I have a cone with the same radius and the same height. And let's say that's the same as the height is the same as the diameter of the sphere. So in order for this to work, it would have to be the case that if this is the radius, and it's all the same radius for all three, then in order for this to line up, the height would have to be the same as twice the radius. So notice here, the height equals 2r. So I have a cylinder, its height is twice its radius. I have a cone, its height is also twice its radius. And then I have a sphere that has that radius. Okay. Let's think about the volumes here. So the volume of this thing is pi r squared h. The volume of this thing is 1/3 pi r squared h. And the volume of this thing is 4/3 pi r cubed. However, voila, the height is twice the radius. So let's plug that in, I get pi r squared times 2r. Here I get 1/3 pi r squared times 2r. And this one just had, didn't have an h in it. So let's rearrange here. R times r squared is r cubed, so this is 2 pi r cubed. Yeah. And this is r times r squared is r cubed again. This is 2/3 pi r cubed. What did I do wrong? I did something wrong. Oh, no, I didn't. I'm losing my mind. This one is 4/3 pi r cubed. You just have to trust yourself, Steve. And now I make a little formula here where I put an equals here and a plus here. And look at that. 2/3 pi r cubed plus 4/3 pi r cubed is 6/3 pi r cubed, but 6/3 is the same as 2. So that means that if you're talking about volume, the volume of the sphere plus the volume of the cone add up to the volume of the cylinder. So that's kind of cool. So again, the volume of the cylinder equals the sum of the volume of this cylinder, sum of this cone and this sphere. It's very specific that here the height has to be twice the radius. So that's kind of a really kind of cool relationship. And this is also one that if you have a cone and a cylinder and a sphere, usually you just have half of a sphere. But if you kind of pour them in, if you have 2 half spheres, you can demonstrate this like with containers if you have the right shapes. Okay, thank you.